Everyone has heard of the famous equation E equals mc squared. What does it mean? Well, Sir Arthur Eddington, an English astrophysicist of the 20th century, concluded that based off of Albert Einstein's discovery of E equals mc squared, or energy equals mass times the speed of light squared, that a massive amount of energy can be released from fusing the nuclei of atoms. He then concluded that the sun, or any star for that matter, gives off energy in this way. Ever since, scientists have been trying to harvest the power of fusion right here on our Earth.
So what is fusion? It is the exact opposite of a nuclear bomb. A nuclear bomb works by splitting atoms with a large nuclei by shooting neutrons at it, a process called fission. Fusion, however, is taking two atoms with small nuclei, usually hydrogen, and smashing them together to create a large atom, usually helium. This process of fusing two atoms gives off a tremendous amount of energy in the form of neutrons, which scientists have been trying to capture and turn into the usable energy right here on Earth.
Nuclear fusion can provide tremendous amount of energy. However, there's a few problems with it. First off, it's hard to control the reaction. Scientists have been trying to control the fusion for a long period of time, and they are able to maintain the fusion for a maximum of quarter of a second. The challenge is to improve the time range. And the second major problem is to get the resources for the fusion reaction. And it requires the hydrogen isotopes such as deuterium and deuterium as a fuel. It is very difficult to get it from the Earth source, but there are few options available. Overall, the obstacle scientists that face is extracting the fuel for the fusion, maintaining the reaction, and funding the experiment to begin with.
In 1951, Argentina claimed that they had created sustainable fusion. This turned out to be a complete and utter lie, but not before sparking an interest in creating nuclear fusion. Soon after, nuclear fusion reactors such as the Zeta, the Tokamak, JET, and NIF's beamlet laser has slowly progressed to creating fusion for nanoseconds at a time. Millions and millions of dollars were spent over the span of 50 years or so, and progress was very slow.
A mixture of two hydrogen isotopes, deuterium and tritium, are an option for fueling nuclear fission. Using tritium have consequences. If it leaks into environment, it could bond with oxygen and create a radioactive water, which has the potential to do a serious damage to all living beings. We can replace the dangerous tritium for a better, safer, and more abundant resource called hydrogen-3. We can get it on Moon. The Moon, which has no magnetic barrier to protect against solar winds, has been building up hydrogen-3 for a long time. Something that our planet cannot do. Basically, we could set up a mining base on the Moon and have an unlimited source of hydrogen-3. So the nuclear fusion is advancing, have a safe and abundant source of fuel. So the only thing that is stopping us is time and lots of money.
Fusion energy is clean, safe, sufficient, and the fuel is virtually limitless. To harness this power of fusion would change life on Earth as we know it. Progress is being made slowly but surely, and if people continue to share information and funding continues to back up research, it may eventually be our primary source of energy.